Have you ever felt like technology is sprinting faster than we can even process? Like every week, a new announcement makes yesterday's innovation feel irrelevant. That's exactly what happened this week in AI. 4 breakthroughs from 4 giants, Meta, Google, ByteDance, and Microsoft, landed almost simultaneously, and they don't just move the field forward, they completely reshape how we think about machines. We're talking about robots that can teach themselves to see, a mini beast of an AI that can run all day on your phone without touching your battery. A tool that lets AI hunt bugs in massive codebases like a digital bloodhound. And a new language, a kind of HTML for AI, that could quietly redefine how humans design prompts forever. It sounds like 4 separate revolutions colliding into one moment. And if you want to stay ahead of the curve, you can't afford to miss this. So let's break them down, starting with Meta's vision model, DinoV3. Meta DinoV3, self-supervised vision. DinoV3 is a milestone because it breaks free from one of AI's oldest chains, the need for endless human-labeled data. Most models can only learn what humans tell them. This is a car, this is a tree, but labeling millions of images is slow, expensive, and finite. DinoV3 trained on 1.7 billion unlabeled images. No human intervention, just pure self-supervised learning, spotting patterns, teaching itself what objects are, and forming a universal understanding of the visual world. This isn't just an academic achievement, it's raw adaptability. Imagine a humanoid robot walking into a factory it has never seen before. Old models would struggle. DinoV3 can instantly map the space, identify hazards, and locate equipment without retraining. The same goes for drones scanning crops, satellites monitoring climate, or rovers exploring alien planets. Its architecture is what researchers call a frozen universal backbone, with 7 billion parameters. Frozen means you don't need to retrain the entire system for every new task. Just attach lightweight adapters. That makes it cheap to run, but extremely versatile. Already, NASA's Jet Propulsion Lab is using DinoV3 to help Mars rovers process visuals with minimal compute. The World Resources Institute cut forest measurement errors in Kenya by 70% using this model. That kind of leap from 4 meters of error down to just over 1 translates to smarter decisions in conservation, agriculture, and climate science. The scale jump from DinoV2 to DinoV3 is staggering, from 142 million images to 1.7 billion. From 1.1 billion parameters to 7 billion. From domain-specific accuracy to outpacing specialists. And here's the big idea: for the first time, robots and AI systems aren't bound by human labor. They can learn from the endless stream of unlabeled data all around us. This is the start of adaptable general-purpose machine vision. But while Meta went massive, Google did something shocking in the opposite direction. Instead of going big, they went tiny. And it might change your phone forever. Google Gemma 3, the mini beast AI. If Meta is building skyscrapers, Google just built a diamond, small, efficient, unbreakable. Their new Gemma 3 model has just 270 million parameters, yet it's so optimized it can run all day on a smartphone without even nudging your battery graph. Why is that revolutionary? Because until now, running serious AI locally on your phone was a battery killer. Most apps offloaded processing to the cloud, meaning your private data had to leave your device. But Gemma 3 flips that equation. It's so compact and power efficient, it can stay entirely on device. The secret sauce is in the quantization-aware training that lets it run at just 4-bit precision with almost no quality loss. In plain English, it can run heavy-duty AI tasks using tiny amounts of memory and energy. Google tested it on a Pixel 9 Pro 25 full AI-driven conversations, less than 1% battery drain. That's not just optimization, that's freedom. And the design philosophy is clever. Not one oversized generalist model, but multiple right-size specialists. Developers can keep several Gemma 3 models on a single phone, maybe one for legal text analysis, another for medical notes, and another for customer support, switching instantly without needing cloud servers. Its vocabulary is built for industries that depend on precision: medicine, law, engineering. No more stumbling over rare or technical terms. And here's the kicker: fine-tuning it for a specific use can take as little as 10 or 20 examples. A small business could spin up a customized AI assistant in a single afternoon. This flips the script on accessibility. Instead of AI being locked behind expensive cloud services, it becomes personal. Your phone, your data, your assistant, always available, never draining your privacy or battery. But while Google shrank AI into your pocket, ByteDance tackled one of the messiest problems in all of software, navigating gigantic codebases. And their solution, it's like arming AI with the instincts of a detective. ByteDance ToolTrain, AI Bug Hunter. If you've ever worked with a massive codebase, you know the pain. A bug shows up and finding the root cause is like searching for a needle in a skyscraper full of haystacks. Traditional search tools don't cut it. Even today's large language models wander aimlessly, chasing wrong leads or spitting out half-baked guesses. ByteDance's ToolTrain changes that game. It doesn't just throw guesses, it learns how to use tools strategically to track bugs step by step. Think of it as giving AI a detective's playbook. Locate a function definition, check dependencies, then decide what to investigate next, without getting lost in irrelevant files. They trained it in 2 stages. First, supervised fine-tuning to teach the basics. Then reinforcement learning, rewarding it for making the right sequence of moves. The result is an agent called Repo Searcher that doesn't just search, it strategizes. And the results? Stunning. On GitHub issues verified by professional developers, ToolTrain's 32B model achieved function-level recall at 5 of 6.8.5, 5, beating Claude 3.7, quote S66.38. Even more impressive, their smaller 7B model outperformed competitors using 32B models. Smaller, faster, more accurate. This isn't just about cleaner code, it's about empowering smaller teams and startups who don't have giant developer armies. Imagine debugging mission-critical systems with an AI partner that doesn't waste time or energy, but narrows in on the bug with surgical precision. In an industry where one bug can cost millions, or even lives, ToolTrain's impact is hard to overstate. But debugging isn't the only bottleneck in AI development. Even when you can build powerful systems, prompts quickly become messy and unmanageable. And that's where Microsoft's surprisingly quiet but radical breakthrough comes in. Microsoft POML, the HTML for AI prompts. At first glance, Microsoft's new prompt orchestration markup language POML looks almost boring. It's not a flashy new model, not a Mars rover vision system. But don't let the name fool you. This could end up being as foundational for AI as HTML was for the web. Here's the problem it solves right now. Prompts are a chaotic mess. Long strings of text, roles, examples, data references, all jumbled together. They're fragile, hard to maintain, and impossible to scale. POML changes that by adding structure. Think of it as semantic tags for prompts. Roles, task, example. Just like HTML organizes web pages, POML organizes AI instructions. That means cleaner prompts, reusable components, and dynamic instructions that don't collapse into spaghetti text. Even better, it separates logic from presentation. Just as CSS lets you redesign a website without touching the content, POML lets you change how an AI responds without rewriting the entire instruction set. Want an answer summarized in bullet points instead of paragraphs? Adjust the formatting layer. No need to retrain or re-engineer. Microsoft is already shipping developer tools, a VS Code extension with syntax highlighting, autocomplete, live previews, plus SDKs for Python and Node.js. It's open source under MIT, already on GitHub, and designed for real-world workflows. The potential here is massive. As AI systems become part of everyday software, prompt management will determine whether they scale cleanly or collapse into chaos. POML offers a foundation, a grammar for AI, that could quietly become the standard developers can't live without. Otro cosa off CTA. So what does this all mean? In one single week, AI made 4 leaps forward. Meta teaching machines to see without labels. Google shrinking intelligence into a pocket-sized mini-beast. ByteDance training AI to debug code like a detective. Microsoft laying the foundation for prompt engineering at scale. Each of these could ripple into industries, jobs and daily life faster than most people expect. The question is, are you going to watch from the sidelines, or find ways to ride this wave? If you're curious about how regular people, not engineers, are already using AI to create new income streams, I've put together something called the AI Income Blueprint. It walks you through 7 methods you can start with no coding skills, and most of it can be automated. It's free for now, but won't be forever. Links in the description. So your turn. Which of these breakthroughs do you think will shape the next 2 years the most? Meta's self-taught vision, Google's on-device intelligence, ByteDance's debugging detective, or Microsoft's prompt language? Drop your thoughts in the comments. Hit subscribe if you haven't, and buckle up. Because if this week is any sign, the future isn't just coming, it's already here.